Hi everyone, in this screencast I'm going to show how to use Excel to calculate some statistics about this set of bivariate data. So the first thing I want to do is plot the data. So I use insert, and then from all the different charts available I'm going to pick a scatter chart which just has the raw data points. I'll slide this over here to the side out of the way. We need to obviously give this a title, so this is just some sample data. The title that you give would be more informative than that. Now I will add into this axis titles, and this is one highlighted, so I'll just put y-axis. Now again, you would be more informative with your work, you wouldn't just type axis title. And then we have an x-axis, because my data is literally just labelled X and Y, whereas yours would be more relevant than that. Now once we have the data plotted, sometimes we wouldn't necessarily want to begin from 0 because we have all this blank space down here. So I can click on that and I can then, that was a right click, format the axis, and I get to choose the minimum value and the maximum. Default it has chosen for me. I'll just leave it at the default for now, but that's how you would personalize it or customize it if you needed. Now the data set itself is an object. I can click on any of the points to highlight the whole thing, and then from this little plus button I can add in a trend line. The trend line, it defaults to be just a straight line, but I can also use this arrow to give me some more choices with the more options. And I'll scroll to the bottom of the page. Here I will display the equation on the chart, and I will display the r squared value, which is the coefficient of determination. Now there is the information that I just wanted. It's always a bit hard to read, so I'll increase the font size a bit, and I'll put a little bit of a background colour, nothing too horrible, just a little bit of background colour to highlight. Now what does this tell me? It tells me that the gradient of the line is 1.49 if I round it, and the intercept is 13.16. Now the trend line just finishes where the data finishes, but if we could imagine that coming all the way down, it would intersect here at 13.16 on the y-axis. That's interesting, and that's important statistics. The r squared value of 0.91, remember this is the coefficient of determination. This would tell me that if I used a model to predict a y value, roughly 92% of the predictive power of the model is due to this association. The other variation, the small variation, would be other factors. Now let's see how we go about doing all these calculations. So on the paper worksheet we had the mean of the x's, and then we had the standard deviation of the x's, and there were two versions of this. There was the population one, and then there was the sample standard deviation. There was the sum of the x's. There was the there was the sum, I'm having a bad day today, the sum of the x squared values. Now these are just text labels, and then there was the sum of the x value multiplied by the y value. That was one list. I'll leave some space to do these calculations. The next list we had the mean of the y values. We had the standard deviation of the y values, and that was the population standard deviation. We had the standard deviation of the y values using the sample. Then we had the sum of the y values. We had the sum of the y squared values, and I'm just using that little symbol there to mean squared. And then we had the number of data points n. I'd like those to be centered, please. That's better. Now I'd better do some calculations. Now fortunately Excel does calculations for us. We begin with an equals key to tell Excel we want a calculation. The command we want is average. and I have to open a bracket, and then I have to highlight the cells that contain the numbers I'm interested in. So see, it says B1, that literally refers to cell here, and the colon means all the way to the cell here, K1. I hit enter and I get the mean of the x's. Same here. I want the average value of the y's. 31.8. There. You would recognise these results from when we did this worksheet by hand. The standard deviation, the formula is ST. Now it starts to suggest things. So STDEV is standard deviation. See the one here with P and S? That's the population, and that's the sample standard. So it's that one we want. I'll just double click. It fills it in for me. And this is the standard deviation of the X values. So I highlight, brackets, and enter. I'll try again. Standard deviation. This time I want the sample standard deviation of the X's. The sum of the X's. Well, there is a command to go sum. Here we go. Sum of the X's. There they are. Brackets. Now this next one is not quite so straightforward. I do not think Excel has a sum of squared values. If I start typing sum, oh, it does have it. Sum. If I click on this, it'll tell me, I'm learning this for the first time, returns the sum of the squares of the arguments. Arguments can be numbers, arrays, names. Well, that's the one I want. The sum of the squares, and I want these ones to be squared. So I highlight them. Now, that is the answer that we did it when 1645 is matching the answer we did manually. So we're on the right track. This is great. Now we have the sum, and let's see, what does that one do? Sums the difference between the squares. That's not what we want. Returns the sum total of the sums of squares of numbers, and no, that's not it. Sums the squares of differences of two. Sum of product. This could be it, because when we have sum of x multiplied by y, x times y is a product. Returns the sum of the products of corresponding ranges or arrays. That's what I need. Array number 1 is the list of x values. Now I'm typing a comma here at this point, and array number 2. Now it would need to match in length. That's what I have. So it will go 8 multiplied by 26. And it'll hold that result, and then it'll go 9 times 25. Each of them will be multiplied and then added up, and I get 4098, which is matching what we got when we did this the other way. Here we go. I'll go a little faster this time. Population standard deviation of the y values. Sample standard deviation of the y values. The sum of the y values. The sum of the squared y values. Now for this last one, the command is count. Counts the number of cells. And I could either count the x's or the y's. I wouldn't count both because there are 10 data points. I just need to count either the x's or the y's. There are 10 data points. There's all of my calculations with the raw data. That's lovely. Now, the next bit we had on the worksheet was the value of the correlation coefficient. So I started typing the word, and my suggestion is returns the correlation coefficient. That's what I need. The first array, I hope, is the x variables. We'll soon find out. The second array, I think it wants the y variables. And I have a correlation of 0.958. And that matches what I had when I worked it out manually. I Of course, remember I can change the decimal places if I want to. So usually 3 or 4 decimal places is sufficient. That was the correlation. That's lovely. The next thing we had was the covariance of x and y. Now the covariance, I don't think there is a formula for this. We will soon find out. Oh my goodness, it does have the covariance formula. This is incredible. So again, it's population or sample. Let's go population, array number 1. I must say I'm very happy by this. I thought I was going to have to calculate it manually. Close the brackets and enter, and I've got 12.3 as the covariance. Exactly what I thought it would be. That's lovely. Now, we've already done the data series. That's good. When we did our graph by hand, we had the data points, and then separately we had the values of the mean point and the intercept. There's no real need for us to have that in Excel because this draws the perfect line for us anyway. The next thing that we did was we calculated the slope and the intercept of the graph, didn't we? And remember, we have the formula. This is just going to be text here. Y equals A plus B times X. That's our formula for a straight line. Now, B, the slope of the line, there is a command, slope, returns the slope of the regression line. So I double click. The Y value, it wants the known Y values first. That's slightly different to the others. And then the X values, it wants the X values second. And there we go, 1.49. Of course, it has to match what was typed here by the computer. The computer worked these both out. Then I want the value of the intercept. So the intercept, there is a formula for the intercept that we could work it out, or we could let Excel do the work for us. So this is the one, calculates the point at which a line intersects the y-axis using the best fit regression line plotted here. Here we go. Known y's, comma, and the known x's. So again, matching what we had over there. So far, so good. The next thing we did was we used the model to calculate these things. Now, we'll actually have to use reference to these now. So when we did the model, we literally had y equaled, instead of A, 13.16 plus 1.49 times x. So we can put a formula of our own design here. The value of A is 13.16, and we just reference that with cell I9. If I press the F4 key, try that again. If I press the F4 key, notice the dollar signs have been added. That's very important. When I copy this equation across, I do not want that cell reference to move. Every one of these needs to look at that cell to get the value of A. Plus, I click on the cell reference for B and I press the F4 key again for the dollar signs, multiplied by, now the formula says B times X. Where is the X value stored for this particular answer? I'll be using the X value here stored in cell B1. Now, I do not want dollar signs on this one. That's calculated out the value predicted by the formula, or the value that I would find on the dotted best line. When I copy this one over, notice that this one, the one here at the front and this one in the middle are both still pointing at the same place. They're both back to there. Well, but the C1 reference has jumped from here to here. Now I needed that. I need the answer here to be using an X value of 9, and so forth all the way across. These are the predictions that the model, the linear regression model, is giving me. Now the residuals. Remember, the definition of a residual is the observed value subtract the predicted value. No dollar signs here. As I copy this one over, if I check this one, it's going C2 subtract C3. Perfect, that's what we need. And let's have a little reality check here. The first residual had a positive amount because the first data point, observed point, was above the trend line, which is the model. The second residual has a negative value because the second data point, which is the observation, is below the trend line. That's the model. That's why it's negative, it's below. And as we go across, that one's positive, third one's above. We have we have 3 negatives in a row, so we have 3 data points below, and so on. That's lovely. Now I want to plot a graph of the residuals. To do this, I highlight the X values, I press the Control key, holding the Control key now, and highlight the residuals. Now I will insert another scatter graph. There it is. And I'll title this as residual. Helps if I can spell. And I will have some axis titles again. This one is the residual value, and this one is the x-axis. Now I'm just going to shrink the graph down a bit, and I'm going to pop that along underneath so that I've got my scatter chart with the x and the y-axis. I've got the x-axis and the residuals. There's the residuals. They're all fairly small. They're randomly scattered. There doesn't seem to be a pattern. I think we have a good, strong positive association here. The residuals show no fixed pattern. They show fairly small values, which means that we have an appropriate model. The linear model is doing a good job on this set of data. And that is how you use Excel to complete the calculations of that worksheet we had last week, rather than manually. This has been a rather long video. Thanks for staying with me all the way through it, and I hope this has helped.